So now we're on to electricity and magnetism. This is the chapter before the last one, and we deal with charge transfer, energy, power, voltage, resistance in a series, resistance in parallel, frequency, and this one deals with transformers. They deal with voltage, number of turns, the current in transformers. And that's pretty much it for electricity. Electricity is a fun exercise, but it's very long. You have to talk about static electricity, you talk about induced electricity, you talk about how you turn up or turn down electricity. And basically, you need to know that electricity is very dangerous when you deal with it, because it can kill you. It can give you a shock, or a shock can be fatal, which is what we refer to as an electrocution. So when you have charge transfer, it's a kit. Q equals to IT, where I stands for amperes and T stands for time. Amperes and time in seconds. The units of Q is C, coulombs. Then we have energy. We have two equations for energy. E equals to the voltage times charge transfer, where E is in joules, and again the E stands for energy, so it's going to be joules. And we have E is equal to power times time. We have the E equals to joules. Power is equal to amperes, or current, times voltage. Amperes is the unit of current, and voltage has the units of volts. And so the units would be watts power. The unit of power is watts. Now, a voltage is equal to the current times resistance. The unit of current is amps, and the unit of resistance is the ohm. For the symbol for volts is V, and so you would have a symbol for volts V. Now, resistance in series is easy. You just add all the resistances together, and it can be more than 2 resistors. That's why we have the dots there. You can have 6 resistors, you can have 7 resistors, and so you would just add all of them once they're in a series circuit, meaning that they're running one behind the other. And the unit for resistance is ohms. Units for resistance, setup resistance, or for resistors set up in parallel circuit, which is like a stepwise. Just think of a ladder, a stepwise fashion, where the current has different pathways, pretty much how your house is wired. So the current would have different pathways to travel. This is calculated by 1 over the total resistance in parallel, and then you have each resistor after that being 1 over that resistor. Please be mindful that you have 1 over arity here. This is more tedious to work out than this on top. This one you have to know a little something about how to add fractions, and the units of this is in ohms. Now, frequency, we learn about periodicity. So if periodicity was T equals to 1 over frequency, then frequency must be equal to 1 over T. I know if you don't know how to transpose, you're probably saying, let me just memorize. No, I'll teach you how not to memorize and how to understand how to transpose. Once you know how to transpose, physics is easy. And so the units of frequency is hertz, or 1 over S. A hertz is per second. Now, when you're dealing with transformers, you're dealing with volts. The number of turns of the wires, which increases with increasing amount of wire. The current increases with increasing amount of turns, and then you have current. The S stands for secondary, and the P stands for primary. So the only thing that changes when it comes to the subscripts is current. With current, unlike the other two, you have the primary on top of the secondary. So this must be remembered, because when you're searching for either one or the other, you need to remember that I is the only different one. V and N stand together, right? So if you're looking for V, voltage, you have V. A is the number of current, the amount of current, and of course N is the turns. Okay, and so that will be the units. And since the last chapter is the smoothest chapter, it is the one that contains the most reading, and it only contains really and truly one equation. We're going to just meld it in with electricity, but we're going to deal with it separately, of course. But so not to waste your time, it also deals with energy. And here again, the units will be joules. In physics of the atom, you deal with fusion, fission, and all that jazz. You learn about why the sun is still such an awesome body, celestial body. And you learn how nuclear plants operate in places that use nuclear energy. And you understand why it is so much cheaper to produce, however, at an expense of your health. Now, E is equal to mc squared, and that was an equation that a very famous scientist came up with, and his name was Albert Einstein. And on your spare time, you should try to read about him, because he was a good physicist, and you will learn a lot of different things. Just look for the simplest literature. Whenever I'm teaching, you look for the simplest literature so that you clear your mind of all that might be had, and then from there you can build on it. You always try to start simple, and if you could stay simple and work smart, you will always pass. You don't have to be all this lots of stuff, and you know how some people say, oh, we do this and then all the arrows going to no. Keep it simple. Keep your pages simple.